Hello, my name is Marcelo Luz Pereira and my teammate is Calaves Camilla, and in this video we're going to explain how the fermentation process works and what do you need for it to work. And so let's get right into it. So before heading out to the explanation of the experiment, we first need to know what does fermentation means. So in few words, fermentation is a process where microorganisms such as yeast or bacteria convert sugars into alcohol, acids, or even gases, often in the absence of oxygen. This process is used, as you can see, in food productions to create products like beer, wine, yogurt, and bread. But in this case, we're not gonna use neither of those products, if not fruits. More specifically, we're gonna use strawberries. So basically, this experiment aims to investigate the effectiveness of vinegar, which is the independent variable, as a natural preservative, focusing on its ability to prolong the shelf life of strawberries. So as you know, vinegar is known for its preservative properties, particularly in preserving vegetables and meat for extended periods. But this experiment seeks to explore whether vinegar can similarly preserve fruits, which typically spoil more quickly. Strawberries were chosen as a test subject due to their tendency to spoil rapidly and their relatively compatible acidity level with vinegar. So the acidity of both strawberries and vinegar, with pH levels of 3 to 3.5 and 2 to 3 respectively, suggests as potentially effective preservation process. So, in few words, the goal is to maintain the strawberries pH within a safe range below 5 to 6 while extending their shelf life beyond the normal. So, the experiment's success will be determined by assessing the strawberries pH levels after the preservation. If the pH remains within the desired range, it indicates that the vinegar effectively preserved the fruit while maintaining its safety for consumption. So now that we have a little bit more of context regarding what we're trying to do with this experiment, now we're going to head out with the materials that we'll require for the realization of this experiment. So first of all, we have the independent variable, which is distilled vinegar. Basically, the distilled vinegar is going to be useful for us because it's going to be the main solvent and it's going to be efficient because of its preservation qualities. And then we have the dependent variable, which are strawberries. In this case, we're not gonna use frozen, but if you're trying to use them, it's gonna be okay. But in our opinion, it is more recommendable to use normal strawberries. Then the other materials are water, white sugar. Also, we're gonna need mint that I don't have right now, but some sprigs of mint will help the mixture to have a more tastier and strong taste. And then a container is gonna be needed. It can be either a plastic one or a glass one, but also in this case we're gonna use a jar, which is gonna be more efficient and it's gonna be more easier for us to maintain the whole mixture in a good state for it to preserve for long periods of time. So these are the materials, and now we're gonna head out with the procedure. So before continuing with the procedure, we first need to know the following things, such as the main objective. So in this case, the objective that we're trying to achieve with the realization of the experiment is to mainly finding a way to preserve the strawberries for long periods of time without affecting their pH levels as much as possible. That's why the fermentation process is a perfect sample to reach this goal. Then our hypothesis is that if the strawberries we preserve successfully by using a natural preservative such as white vinegar to conserve the strawberries longer than normal. So in the experiment we're going to prove this hypothesis if it's correct or wrong. Then now we're gonna talk about the following variables. As I said previously, the independent variable is a quantity that we're going to implement of distilled vinegar. then the dependent variable is gonna be the pH level not only of the strawberries, if not of the whole solution. The constants, there are several, which are the type of berries, the size of jar, and the environmental conditions in which the container is in. Then the control group, also we have several ones, which are the duration of the experiment, the storage room conditions that in fact are gonna be a cold environment, and the specific brands of vinegar and strawberries. So now that we already talked about these important things, now we're gonna head out with the most important part of the experiment, which is the procedure. So now that we know what materials do we need for the realization of the experiment, now we're gonna head out to the procedure. Step 1. Insert 1 pound of strawberries into the main container. Then add 2 to 5 sprigs of mint. Next, in another container, add 1/4 cups of white sugar. Then put 3/4 of white vinegar, which is the main solvent, in the same container. Then one half of water will be added to the solution. So that's the right amount because it's gonna help us to dissolve the whole solution. So after that, the solution will require to be mixed. Then it will be necessary to then boil the mixture exactly at 100 degrees Celsius. Then we will require to leave it there for about 5 minutes for it to cool down. Then we need to take the mixture out from the boiling place and insert the whole solution into the main container, which contains the strawberries, which are the dependent variables. Then close the container that stores the whole solution and leave it there for about 10 minutes. Finally, after some repose, store the whole container somewhere cool. We recommend to place the container in a cool environment, for example in the fridge, for about 3 to 5 days. Then finally, use the pH level strips to measure the acidic level of strawberries and then compare it with the next 2 trials. So for this experiment, we also did 3 more trials. We followed the same procedure, but the only thing that we changed were the amount of distilled vinegar and the storage time. So in the first trial, we insert 3/4 of distilled vinegar and the time of storage was 18 hours and the results were a pH level of 5. In the second trial, we insert 1.5 cups of distilled vinegar and we left it there for about 24 hours. But again, the results were the same. It reached a level 5 of pH level. But in the third trial, we noticed some new changes. So the inserted amount of distilled vinegar was 2/4 cups of distilled vinegar, and the time we increased it a little bit more, which was 48 hours, meaning 2 days, and we noticed that the pH level increased significantly, which gave us a result of a acidic level of 6, meaning that we believe that the time was the variable that caused the changes in the trial 3, because one of the effects that the changes had on the dependent variable was that the solution literally extracted all the fluids inside the strawberry. That's why the strawberry red color fade out.
We take the 2 samples of the fermented strawberries from the fridge. We will compare the 2 of them with different quantities each. In the first one that we did, we put some same amount of vinegar and water and sugar, half a cup of sugar, and only 3 strawberries. We can see that the coloration of this bottle of strawberries, fermented strawberries, is reddish, which I suppose is because of the big quantity of the strawberries compared with the other materials that we use. And in the other flask, we can see that it's more pale. It's much murky than the first one that we did. They are pale, and the reason for this is because we add more vinegar and sugar than strawberries. That's what I suppose. And well, after the explanation, I will pour the container of the two flasks in two plates, and then we're going to heat them so that we can see the results of them for 10 minutes. This is the second try with all the mint, and now the second plate we're going to put the first try that we did. I also have to add that in the first try, the strawberries have a variable that we didn't expect, that were fungi. This come as a surprise and an unexpected variable, but we can see that thanks to the vinegar, it's now cleansed from all the fungi that was on it. So I think that our fermentation experiment is going in the right path. Now that we have the two results of the different tries of the strawberries that we did, we can see that the ones that were affected the most were the first one, since there were less quantities of each element. There was less vinegar, less water, and a lot less strawberries. However, they still preserve very well and still have, in my opinion, favorable conditions for digestibility, and are preserved successfully. The second ones, on the other hand, seems just like they were placed in the first place on the microwave. They were seen much less affected than the first one, and I think that the reason for this is the amount of vinegar, water, and strawberries that is on it. And they were also successfully capable of preserve the strawberries of pathogens and hazards, bacteria and fungi. So I would consider that the two tries that we did on the practice of this experiment are successfully, and the two strawberries are ready for digestion.
So, based on the given results that the experiment gave us, we can conclude that the results were satisfying as we expected. Since the fruits were preserved successfully for a maximum of 2 days and were still in an intact state, and also because of the fact that the pH level didn't change that much. So, as you know, the ideal pH level that we wanted to obtain was around 5 to 6, and we successfully reached the same level, which means that its acidic level is moderate. And most importantly, the juice and nutrients of the fruit were extracted, which makes the vinegar solution more adaptable to the strawberry, which is good because, as you know, the diesel vinegar was the main solvent, and also it compromised with its purpose. So, in a few words, the first trial was made accurately to learn the required changes that we needed to implement in other trials to explore the limits of this interesting experiment and process. Even though we know that this process could reach more of its capacity, the given time wasn't that favorable. But in the end, the implemented goals were reached efficiently. So, thank you very much for seeing this video experiment, and we expect that you learn so much of this interesting process because it's a fascinating process and it is easy to make. It is more easier than expected, and we expect for you to learn regarding this process. So thank you very much and have a nice day.